Let's take a look at a robust, industry-proven toolset in the ArcGIS system and how it can be used to support railroad mapping, and that's the ArcGIS Utility Network. First, what is it? Well, it's a component of ArcGIS that provides tools for working with a variety of different kinds of networks. As its name implies, the most popular uses are with various utilities and the assets that they manage and operations they perform, such as electric, gas, water, wastewater, and telecom. For them, it's not enough to manage and visualize their assets on a map. Utility Network provides the ability to design rules and behavior that individual asset types have. For example, there are rules about what kinds of electric distribution lines can connect and not connect with other types of equipment, or how many transformers are allowed to connect to a pole, and so on. You can also trace the impact of damage to the system. For example, what houses will have their water cut off if a water main is damaged in a certain spot. While its use in transportation has been limited so far, we see value in the way that it works for transportation, since it's also a domain where digitizing the world into points, lines, and polygons isn't enough. You want to design rules into the objects so that you can better manage the overall system. Here's a nice image showing how the real world is modeled into a digital twin. And by twin, not just in the way the system appears, but also how it works. As you can see below, this natural gas network is designed with many different types of equipment, each with its own behavior. We're already starting to see the usefulness with railroad networks, not only to trace the flow of trains and seeing how different parts of the system are connected when switches are activated, but it can also be helpful when running an isolation trace to decide which switches need to be activated in order to flag out a section of track to perform maintenance safely. Another advantage here is that railroads are often associated with other kinds of networks. In the graphic here at the top left, what you're seeing is a rail line and an electric line associated side by side. Quite a number of railroads are electric powered, for example, using overhead catenaries or third rails. And wayside equipment like signals and crossing arms need power also. Utility Network gives you a way to design and model associations between these networks, managing flow, supporting maintenance, and so forth. In the upper right, you can also see that in addition to working with your maps geographically, Utility Network recognizes that a schematic view can sometimes be the best way to visualize the system. Within Utility Network are tools for automatically generating and interactively editing schematic diagrams. So whether you want that schematic diagram to be live and interactive, or to support your update and publishing of track charts, these tools come in handy. Okay, let's see how this works. Using ArcGIS, we've built a utility network on this rail data. Of course, a robust GIS database for rail data includes a lot more, but to demonstrate, all you see here are a polyline layer of tracks and a point layer of railroad switches, which become the edges and junctions in the utility network. Here you see a rail line that splits into two using a track switch. When I perform traces or find shortest paths, these tools will respect the behavioral rules of the switch, not only modeling how switches work, but how they behave when set in different ways. So let's say I have a train that's going from here to here, and then I do a shortest path trace. A path will be found because this switch here is in its default setting to allow the train to proceed along the main track. If I move the trace location to this spur track, then run the shortest path trace again, I'll find that a trace cannot be found. No path was discovered because of the setting of this switch disconnects this section of track with this section of track. But if I modify the terminal path of this switch so that instead of staying on the main track, it goes to the right, and then I validate the topology, and then try running a shortest path trace again, I'll find that a path is now found. It goes through the switch, turns to the right, and continues. What we're doing here is modeling the real-world behavior of track switches onto the switch devices being mapped in the GIS. Here at the top is a switch being activated in order to direct the train's path this way or that way. A train can go out this way or out that way and can approach from this direction or that direction. It can do one or the other, but it can't do both at the same time. Another thing a train cannot do is come in from this way and go back out that way. So looking at this graphic here in the lower left, you can see 8 valid directions in green, but only 2 at a time can be done. And as you might imagine, the 4 red paths are not possible no matter how the switch is set. A train cannot fold back on itself like that, so we want to make sure that we model it the same way in the network. Once the behavior of the switches are built in, one of the things we could do with these switches is to model maintenance of way operations in the field. If I have some maintenance that needs to occur on this section of track, we need to flag it out so that the trains don't interfere. Setting these 4 switches here allows the trains to continue traveling north and south, but still allowing work to continue on this section, which has been isolated from the network. Okay, so let's see how that works. Let's go ahead and do that. We already have this switch up here, which directs the train to the west. I could do the same for this switch here, which directs the train off of the loop and back onto the main track. And then I go back to my trace locations. I remove the second trace location and I add it down here. So now, if I look up the entire section, I'm going to be going from this part of the main track to this part of the main track, but I'm going to be using this loop rather than the main track. Let's go ahead and run that trace. And doing so, a new path is found from the main track up here to the main track down there. Now, if I zoom in, you can see a little bit better what's going on. We bypass the main track to the west. And then after that length of track, it rejoins the main track down here. So what's going on is this section of the main track is now isolated from the network for maintenance to occur here. So that's it, a simple example of modeling the behavior of a railroad on a map using ArcGIS.